Hello? Test? Can you guys hear me? Can you hear me? Hello? Welcome to my first GRE Prep stream. Thanks for stopping by. We're going to get started here in a second. I'm going to leave a little bit of time for some people to get in here if they want, but we're going to get into it in just a second. Awesome. Awesome. I guess while we're waiting, does anybody have any questions for me? Since you guys probably know Michael a lot better than me, so I'm here. Probably a few more minutes to just chill and talk before we get started. Hello. How's everybody's day been? Whew. I've just been prepping the stream all day, so mine's been it's been pretty good actually. It's been really fun to set everything up and get it all going. Hopefully we don't have any technical issues. Streams are famous for just crapping out on you. Yeah, my day's good. Thanks for asking. We got 15 people in here. That's pretty good. I guess I can just give myself an old-fashioned introduction. So my name's Justin. I am like the channel assistant. I'm helping out Michael with both the main and the second channel, but I'm going to be doing most of my work on the second channel here. I'm going to be trying to do these streams, for those of you who didn't see the update video, every Monday and Friday. And I said in the chat there, but some of you might just be getting in. I'm going to try to get them started between 11 a.m. and 1 p.m. EST. I'll probably be eating lunch, as early as 11, so after I'm done eating. But, not this late normally. Just today was a little bit slower going. Hi, Diego. But yes, I am, let's see, what did Eric say? Yes, I would highly recommend getting a math degree if you want to pursue graduate school in math. And I can say that confidently because I am someone who transferred from a mechanical engineering program into a math major and then finished in about 3 semesters. And I can say I took a lot of math for engineering, and the way you learn math as an engineer is not really comparable to how you learn it as a mathematician. There may be other majors that do better. I think physics might take math a little more seriously, but I thought when I was an engineer, oh, I know math, and then you get into the math major and you realize that everything you've done is not to the letter of the law. I took a lot of calculus classes and didn't pay attention to the details or the definitions, kind of just practically problem solving. And if you do that, you're going to be missing out on a lot of material, and it'll come back to bite you. So, I studied really hard these last 3 semesters, but I feel like I'm still relatively new to the undergraduate level of math. So I would highly recommend getting a math major if you want to pursue graduate level math. But I think you probably could do it if you took a different major. You just have to be careful about it and really pay attention in your math classes. Yeah, they're just completely different animals, and it's kind of hard to compare them because, when you're a math major, once you get to 304, light just went out. Once you get to 304 and 100 level math major classes, you realize how completely different they actually are. Because like I said, when you're taking engineering or really any that light just gonna be out. I don't know. When you take engineering classes, it's a whole different beast from math major. Yeah, I would recommend the undergraduate degree. I think you probably can self-study, but that's exceedingly difficult. I think you probably want to have a teacher somewhere that you can consult. But yeah, I took mech fully through sophomore curriculum and then graduated in a year and a half. So in total, my undergraduate experience was 4 years, but I had a big major switch, and I think I took a year off. And that light's gonna be bothering us, isn't it? I took a year off during COVID to figure stuff out and figure what I wanted to do, and I ended up at Randolph College, and it couldn't have possibly turned out better for me because I have this opportunity available. But yeah, I interned for Michael on the main channel and that is seriously annoying me. I don't want to turn it off though because I won't have any good lighting. I guess we'll just have to deal with it. It's a raven here. But yeah, so highly recommend the math major, and it's been really good. So yeah, for this stream, I have this it's a GRE Prep website that me and Michael found. Let's see, let me read it. It's from the University of Chicago REU, It has 6 weeks of material plus some extra problems, and then it has let's see, six. If I can't count, 6 practice tests. So I'm going to be going through the problems on this website. I can actually link it to you in the description, in the comments if you want to follow along. But I'll have it up on the screen while I'm going through and talking about the problems, so you can see. I'm going to be working it out on the iPad, like right down here, and I have the ability to swap, so you can see my desktop, but my face cam doesn't work on both tabs for some reason, so that's kind of annoying. But we're still working out the kinks. Yeah. Yeah, self-study's good. I did an independent study of topology. I mean, I say independent, but Michael helped me out a lot. But, I mean, I really went in deep and went in hard in the paint, but I felt like I really needed that in-classroom experience that I had, and it's nice to have that resource. So if you have anybody that you know, like a math person that's like an advisor or whatever, the GRE is what's it called? The Graduate Record Exam, I think, something like that. It's basically the exam you take before you go into grad school. Now, in America, the graduate exam in a lot of universities now is not required. They don't even consider it. It's like they're trying to move away from standardized testing, which I sort of get. But for me, this is more like a progress check and to keep me honest, because like I said, I transferred from an engineering curriculum, and I feel like I don't really understand math as thoroughly as I'd want to, because I kind of got my math major in 3 semesters instead of 4 full years. And I want to take this gap year to kind of like do this job with the channel, but also like keep myself accountable and really like patch up a lot of the holes I have. That way I can hit grad school and hit the ground running. I don't really think the score matters so much as me just staying honest. How would you decide whether to pick a theoretical physics degree or a math degree? I think it's really up to you. And that kind of goes with that question. What made you change your major? For me personally, I found, I got through, like I said, 2 full years of mechanical engineering curriculum. And I found that when I was doing my major classes, which those are supposed to be the fun classes, right? When I was doing my major classes, I kind of felt like I was hitting my head against the wall more often than not and not really enjoying it. And I thought back to the classes I really enjoyed, and those were most specifically Calc 3. And I enjoyed a lot of politics classes at Randolph. I had taken Randolph for dual enrollment for 1 year in high school, so I experienced that. And Randolph's the college that Michael works at, for the record. But, yeah, so I found the physics application just made me want to die. That's pretty much why I picked math. But I really think it's up to you. Like, I found once I started to dig into the math major, I enjoyed every single class all the way through. Like, I loved even the stuff that's hard and the stuff like I'd be scratching my head in front of a blackboard for hours. I enjoyed it in a way that I never, ever enjoyed physics or any physics application. So, I mean, for me personally, it was just a matter of, like, enjoyment. I like the rigor of physics. I like the rigor of engineering. I like the difficulty, and I didn't really want to sacrifice that. So I went to math, and I love it. I've loved it ever since. Yeah, it's fantastic. Yeah, I mean, labs were killer. I took like 1 credit labs, and I spent more hours on that than like 2 or 3 lectures for the same. I mean, it was just ridiculous. You had to write like a 10-page lab report every week, and it's on like super highly specified data and theory, and it's just terrible. Yeah, another thing is math is a more applicable major. Like, you can get a ton of jobs in math. Like, one of my friends, I think, graduated with math and physics and went on to get an engineering graduate degree. I think you can apply math to nearly any graduate program. So if you're really on the fence, I would consider the fact that math's probably more applicable than a physics degree, but don't quote me on that. That's gotta rep my major. Yeah. There's a lot out there for sure. I think that, to each their own. But yeah, like I said, for my personal journey, I took a lot of college. Did 2 years of dual enrollment in high school and then 4 years out of high school, and I'm incredibly glad that I had that much time to make up my mind, because I think I would not have ended up anywhere near anything I wanted to do this fast if I didn't. And I know some people are quicker to make up their mind. I've met a lot of people in college that were like from the beginning, like freshman year, they just knew what they wanted to do and they went after it, and I respect the heck out of people for that. But I think most people need some time to figure stuff out, and I think college is a really stressful environment to do that in, because a lot of times you're going into debt to pay for it, but I think ultimately you need to do what's best for you and figure it out after, because being successful is like more important than any specific degree, right? Like, and being happy, obviously, but you want to go into a field where you're happy and you can excel, as opposed to one that's like pain and suffering. I am considering to do a PhD. I really want to go into a PhD program. I haven't really looked at schools in any sort of specificity yet. Like, I'm aware of the good programs in my area, but I really do want to get a PhD and teach both my parents are in education, and it's the kind of thing where I said growing up, oh, never going into education. I got two teachers for parents, and then, yeah. now I'm going into education. My mom's actually a professor at Randolph as well. She teaches biology and botany, and I can't stand either one of those. So I guess any more questions before we get into it? It's been good to talk to you guys. Yes. All right, I think we are good. Any unsolved math problems you would like to attempt? That's pretty much what we're doing here. For these types of streams, I'm going to try to have my answers pretty prepared to kind of like show that I am studying for the GRE more than like do problems live. But I'm hoping to progress as we study to more just completely like, I've never seen this problem before, let's do it. Because, you know, I think that'll be interesting as well. But I think at my current level, it's probably more beneficial to you guys as an audience to see me present solutions that are fairly prepared, because if I'm just going to sit here for an hour and try to figure out something that you guys already know, it's going to be annoying for both of us. So that's where we're going there. So yeah, for 100%, we're going to be doing math problems that are like unprepared, but probably we're going to like progress there, you know. So right now I'm going to be sort of going over problems. Yeah, I didn't link the website yet. I can do that for you. I think you can just look it up. It's called it's like matthewchicago.edu, and it's a GRE Prep thing. I think we just Googled this like really, really quickly. So like we didn't like go through the archives, but yeah. So we're gonna be going through week 1. I think I'm gonna split up these streams and try to do one of those like weeks per week. Oops, I just X'd it out. Well, it's a good thing I just put the link in the comments, right? But yeah, I'm going to be trying to do half the problems on Monday and then the other half of the problems on Friday. That way we can keep up that pace of one per week. And then, like I said, we'll probably try to do those practice exams after I'm done. And maybe try to do those like completely blind. And then it'll be funny if I still don't get it. But yeah, I guess I should get into the math, right? Yeah. Boo, stop talking. We don't like you. Yeah. Yeah, so I like to think I have decent handwriting, but I'm not used to the iPad 100% yet, so forgive any, terrible handwriting mistakes and also mathematical mistakes. But some of these are pretty easy. I guess I will share my screen with those of you who don't have it open so you can see what our first problem is. Can you hear me now? I don't know what happened. Can you hear me now? Can you hear me now? Yeah, I changed. I didn't set up the mic on the other OBS. See, this is first stream problems, right? I always say this. I've streamed before. I've streamed video games before, and you can set it up as much as you want. Something is always going to go wrong. Always going to go wrong. I also think I just wrote all this way you couldn't see, but it's all right. We're learning.
I'm going to quickly see if I can set up the mic on the second scene before we continue, just so that we don't have this issue anymore. If I can't set it up, then maybe I just won't use the second scene. I'll just write out the problems on the paper so you can see it just to save time. So let me see if I can do that real quick. All right, can you hear me on... Oh, no, that's not good.
Can you hear me now? On this screen? I can't check the chat while it's up, but I'm going to assume that you can hear me. Hopefully, perhaps. I have faith in my abilities. All right. Let's see. Life is learning experience. There's an echo. Yeah, I think I fixed the echo. Yeah, okay, good. Yeah, I had two mics at the same time. I think the default is for the computer. Oh, is my face cam not working now? Oh, it's always something, isn't it? I just did this already, had no issue. I swapped to and from, no issue, and of course this happens. I don't even know how to fix that. I might be able to reset it up. Just like set up the face cam again like I just set up the audio. So let me try that, I guess. Let's remove this. You should still be able to hear me though.
Alrighty. Oh, geez, it's huge. Oh, no. Nothing is allowed to go right. I'm going to stay on this tab. I don't like this. I don't like this at all. This is not... It's not allowed to go right. It's never allowed to go right. It can't be perfect. It's scuffed. Oh no. The echo's back. Oh dear.
Alright. Gone. Fixed. It's all fixed. I hope. Tell me it's fixed, chat, and then I can move on with this linear algebra problem. Yeah. Hope. Is it fixed? Is there more echo? Gone? Yes. Perfect. Excellent. Yeah. That's how long the stream delay is, by the way, if you wanted to know. Okay. Yeah. I think I'm just going to keep it on this screen. I'll write out the problems. I'll swap on my second monitor so I can see them. If you want to see the link so you can follow along on your own screen, I can link it to you again. I already gave it to the chat, though. And I'm just going to go ahead and move forward. So let's see here. So yeah, we have this solution for y equals -2 and x equals 1. And we already have these values for a times this. So we want to find the value of a14. So we have a14 equals a, and then I'm just going to write times 1 because it's our x there. 5, 6. No. I need to put the value in 3. We have, so a56 is equal to 3, and a of 2, 1 is equal to -1, but we have our -2 there, so -1 times -2 is +2, so it'll be 3 plus 2. And that means our a14 is equal to 5, and that is the first problem. And if you are following along on your screen, that is answer choice D. Yes. So that is the first problem. Congrats, we've done it. No issues at all. We did it. First try. Absolutely no issues. Okay. The second problem is quite a doozy, so I'm glad we got that out of the way there. Alrighty, I'll go on to the next page. I think I have enough pages for this, but it's entirely possible I don't, so we'll find out. Let me zoom in a bit here. Excuse me. So our second problem is the integral from 0 to infinity of cosine alpha x minus cosine beta x all over x dx. Okay. So to set up this problem, we are going to use something called the Froulani integral. You can look that up while you're following along or not. And so we're going to let 0 and infinity bound these two different r's here. That's a b. That is not an r. I tried. Oh dear. See, I said forgive my handwriting, but it's already begun. All right, so then we have the following. We can write our integral from little r to big R of cosine alpha x minus cosine beta x over x. And we can split that up in the following way into two different parts here over that minus sign. So the integral from little r to big R of cosine alpha x, oh dear, my handwriting's getting worse, dx, I don't know, minus the integral little r big R cosine beta x over x. So split it up like that. Now we're going to parameterize these two. We're going to let t equal alpha x in the first one and beta x in the second one. And so that will give us this right here. Is the bottom beta? Yes. Is there any way of solving this without knowing what the Froulani integral is? I'm assuming there is. I don't know how. I just found this integral and it's very helpful. This integral is quite difficult. If you find an easier way on your own, you can let me know. I'm by no means an expert. That's why I'm studying. But yeah, I mean, you can let me know which you may find. I bet you there is an easier way. It's just not. I don't know it. So this will be. Oh dear. This will be from like this, because we're integrating t over both of these here. That's not an alpha. That's a beta. You'll see where I'm going with this in a second. Of cos t over t dt. Like that. So that's after our parameterization. Ooh. Okay, so now we're going to split that up again so that we have the following two integrals, and then we're going to name those two. So I'm going to write them as like two separate integrals and name them. So I'm going to name the first one h of little r, and that's going to be equal to the integral from alpha little r beta little r of cos t over t dt. And this is going to be g of, I believe, big R, yes, is the integral from alpha big R to alpha big R. And then we'll have cos t over t dt again. And remember, these are being subtracted. I'm just writing them separately here, and I'm going to work them each separately. I'm going to start with this first one, this h of r, and I'll do that on the next page because we are out of room here. So let's see. We have. Go through my notes here. Sorry if I'm looking away a lot. I got lots of stuff in my way. This desk I thought was huge. It's got like 3 shelves up here. It's like really long this way, and it still feels so crammed with everything I've got in here. I think I might buy a desk. That way I can set things up properly, because this is like built into the wall. And even though it's a lot of space to work, it's not like a lot of space to stream, if that makes any sense. I don't know. I feel like if you're streaming. Yes, you can eliminate some answer choices. I'm just going to go through. There's actually a lot of ways you could like go about eliminating answer choices instead of just solving directly. But I think solving directly is usually more enlightening for a study type of thing. But I can go over some of the like answer choice eliminating ones. Like for some integrals, you could just differentiate the answer choices instead of taking the integral, and that might be easier. Just as an example. But yeah, so I mean, there's ways you can go about it for sure. And like I said, my way is by no means the best, and not even necessarily mistake free. But I hope it is. I try. Okay, so for h of r, let me just rewrite that again so you know what we're working with here. We've got integral from alpha little r to beta little r of cos t over t dt. We are going to use the mean volume theorem for integrals, so really likes to switch to the eraser, doesn't it? It just did it again. Come on now. My hands are failing me here. We're going to use the MVT for integrals. And with that, we can extract an element from this. So that means we can rewrite our h of r in the following way. That's going to be equal to cosine of a. That's the element we are extracting here by the mean value theorem. And then we'll have what's left on the inside is the integral from alpha r to beta r of dt over t. And obviously integrating that's going to be extremely easy. We're going to have, that's going to equal the natural log of alpha r minus the natural log of beta r, just by fundamental theorem of calculus. And we can use log rules to cancel out our r's there, which will give us the natural log of alpha over beta. And then we have to deal with this cosine thing out front. So using the mean value theorem again, we have that a is equal to alpha r plus, oh, actually, hold on. So we're going to have for some s on the interval 0, 1, we have this evaluation for a. A is equal to alpha r plus 1 minus s times beta minus alpha r. And we are going to take the limit of this whole thing, that being cos a times this natural log here. So we're going to take the limit as r goes to 0 from above of cos of a with that evaluation for, or that, what's it called, definition for a there. Cos a times the natural log of alpha over beta. And we were fortunate enough to get rid of our r's here, so we don't have to worry about any zeros in this natural log here. And from this definition of a, we can see that this is going to be the cos of 0, which will make this be go to 1, and that will give us our final evaluation for h of r. H of r is equal to the natural log of alpha over beta. And we can move on to the next half of our integral that we split up. Let me check the chat real quick. Is the intention of the question to eliminate wrong answers with careful beta choices rather than actually solve the integral? No, I am solving the integral, yeah. So I split the integral up here. Let me go to the last page for you, if I can. Yeah, so I split the integral up into these two pieces where this original integral is equal to, here, let me just write this out for you, is equal to hr minus gr. And so we've just solved our hr portion, which is the natural log of alpha over beta, using the mean value theorem for integrals. And I'm going to do the second part after this, and then we will combine them to get our final answer, which will hopefully be an answer choice. So let's see. For the second half, we have, what did I call it? G? G of r, yes. We have G of r, let's rewrite that real quick from my notes, is alpha big R beta big R of cos t over t dt. Now this one's actually much easier than the first one because we can just use, this is a fact that I found that makes this integral very, very easy. We know that the integral from 1 to infinity of cos t over t dt converges by the Dirichlet test. Here we go. So you can see, how do you spell Dirichlet? C-H-L-E-T? That's a real math major question. How do you spell Dirichlet? I don't know. I only know Dirichlet from analysis classes. The Dirichlet function, I think. That's it. It's a classic example. Did I spell it right? Dirichlet. Did I? Yes. I'm proud of myself. All right. And converges by the Dirichlet test. So we're going to be able to use that to help us out a bunch. So we can split this integral up into two pieces here. Let's just kind of like do this, and hopefully it doesn't end up too messy. So we can split this up into, here, not J, J, G, you know, what's the difference? G R is equal to the integral from 1 to beta R of cos t over t dt minus the integral from 1 to alpha R of cos t, that whole thing. We've said it 10 times at this point. Cos t over t dt. And now we can take the limit as big R goes to infinity. Of these integrals here. So we have 1 to infinity of cos t over t dt. Oh, did I write that wrong? Oh no, yeah, no, that's what we're doing. Because when you plug in infinity for R, you get infinity there, and then minus infinity 1 to infinity of cos t over t dt, and we can see that from this we get what we want here. So both of these two are exactly the same when you take the limit, which means obviously if you subtract something from itself, you get 0. So that means this half of the integral is 0. Yeah, exactly. So that means our entire evaluation for our integral, we didn't give it a name, but that means the whole integral is equal to, what was it? I think it was the natural log of alpha over beta, yeah. So natural log of alpha over beta is the only kind of contributing piece here. And hopefully that is an answer choice. Let me check. Yes, that is an answer choice. That is E. Okay, cool. So far, so good. It should not be -1 to infinity. All right, let's look at number 3. Or I'll look at number 3 and write it out for you. So yeah, this is actually a good example. I don't know how many of you guys have it open on your screens, but this is the integral, the indefinite integral of dx over 1 plus e to the x. Excuse me. And all the answer choices are, you could probably take the derivative of to find out which one gives you this answer choice. So this is a good example of one you could do by eliminating answer choices. But then I would have to do 5 problems instead of 1, so I'm just going to do the integral here, even if it might take me a little longer. So let me write out this integral for you guys. This is number 3. And this is the integral, infinite integral of dx over 1 plus e to the x. Whew. Talking this much, I need water. Alrighty. So let's see. We are going to start this off by multiplying by e to the negative x over e to the negative x. And that is going to give us the integral of e to the negative x dx over, oh, move the iPad there, over, too much better the second time, 1 plus e to the negative x. And that's because when you multiply the e to the negative x, the 1 from the original integral becomes e to the negative x, and the e to the x becomes the 1. So kind of like swaps like that. And from there, we're going to do a u substitution. So we're going to let u equal e to the negative x dx, or equal negative e to the x dx. Did I miss a negative? No, that's right. No. We're going to let u equal 1 plus e to the negative x, otherwise the substitution is not going to work at all. And that means that du is going to be equal to negative e to the negative x dx. And so now we are going to make that substitution, so that will give us the integral, and we can see that this part is going to be our du, and this part is going to be u. du, this is terrible handwriting, and u. So that gives us the integral of, I guess that's negative there, negative du over u. And that's an easy integral to evaluate. We're going to have the negative natural log of 1 plus e to the negative x. And using our logarithm rules, we can write that as the natural log of 1 over 1 plus e to the negative x. And we can simplify that further by multiplying inside here. Let me just kind of like draw an arrow like this, I guess. Multiplying inside by by e to the x over e to the x. And that will give us the natural log of e to the x over 1 plus e to the x, kind of undoing what we did in the original step. And that will simplify to x minus the natural log of 1 plus e to the negative x. Let me check the chat now. Sorry. Multiply top and bottom. Yes. Yeah. Any questions on that one? I didn't really take questions on the last one, but I don't know how many I could have answered. It's, I had to look up stuff for the second one. Makes sense. We're good? I should wait for stream delay. How do you come up with e to the negative x multiplication idea? I don't know. I think, well, you're trying to set up a u-sub, right? Will I do multivariable integration? Yes, we have a calculus 3 problem coming up. Oh, it's just fine. The stream, for those of you who have missed the first half of the stream or missed any of the stream, it is going to be available afterwards. I might trim some of our technical difficulties. I don't know how good the YouTube editor is, but I'll see what I can do. But all these streams are going to be available after the fact for you to watch, so you can kind of slow down and go through it and then pick out mistakes I may have made in the comments, and we can all learn from it. So don't worry about missing the stream. Happy to have you here. But yeah, no, the reason you multiply with the e to the negative x idea is you're trying to set up a u substitution, and you know, like, you can do that a number of ways. You know, when you're trying to solve integrals, there's a lot of different things you can do to manipulate them to, come to your solution, but that is the one that works out here, so that we can make that u substitution there, and that makes this integral very easy. Any other questions? Give myself a break too. I hope I'm not, I can't really tell what I look like on camera when I'm like looking down and writing, but I might try to get like a workstation to prop up the iPad so I'm like looking forward a little more instead of like down, because of my desk. I'm actually very tall, so I'm kind of like sitting down in my chair so my head doesn't get cut off. It says we have a warning for the video resolution. Is everything alright on the video resolution? We're not sitting in like 144p, are we? I hope not. Alright, while I wait for those questions from the delay, I will write out the fourth question here. Oh, this one's fun. This is a huge word problem, so let's see. So we have n women and m men seated in a row of n plus m chairs. And the question is, if the seating arrangement is chosen at random, what's the probability that all of the men will be sitting next to each other in m consecutive positions? So what is the probability of all men sitting next to each other? Okay, so we can do this kind of like a general rule is you want to have like the odds for like the situation you're trying to achieve over the odds of like the total odds of anything happening. So let's kind of draw a picture so we can visualize this. Got a bunch of seats. Got m plus n seats. So we want to write like write general rule. We want to have the you're going to be like really general with this rule. The stuff you, oops, my Y kind of fell apart there. You want over the total. So in this case, the stuff we want is going to be like the total number of starting point, total number of ways to select. Sorry, my brain just fell apart. The total number of starting points that there are for the men to sit consecutively. So that's going to be you're going to have n. I guess the question is, which seat is the last seat, like going down the line, that the men can all sit in and fit all the way down the row? And that's going to be the n plus 1 seat. That's the very last seat that the men can fit on to go all the way to the end of the row and not run out of chairs. So on the top, we're going to have n plus 1. And then on the bottom, we want to write the odds of every possible seating combination, and that is going to be represented here by m plus n over m, or n plus m, choose m, sorry. And then all we have to do is simplify that, because that is not an answer choice, unfortunately. Let me see what the answer choices are here. Yeah, so let's write our definition for m choose n, or write this out, expand it. So we're going to have n plus 1 on the top, and then expanding that bottom piece down there, we will have m plus n, here, let's get a parenthesis in there, factorial over m factorial n factorial. And we can see when we flip that over, we're going to get m factorial times n plus 1 factorial all over m plus n factorial. And that is hopefully an answer choice. Yes, that is answer choice E. E. I haven't been writing those, but yeah, it's E. Get back to you, chat. It's the number of men. Yeah, it's outdated, man. It's just men and women. We got more than that going on now. Yep, that's right. That's right. Glad you guys are following along. Alrighty. Any questions on that before I move on? We're going to do 11 of these problems, so we're like coming up on halfway. For those of you who are maybe running out of steam, I don't know how much math you guys can sit through. I'm personally a person that, like, my motivation comes in huge waves. I'm a procrastinator, so I'll do a bunch of work in a very short period of time and then get burned out for a long time and then do it again. It's not yeah, GoodNotes is kind of weird. I'm still getting used to it. Like, I'm by no means an expert with GoodNotes. I've been doing this for the example videos and I still don't feel super comfortable. But now you guys can see, usually when I record an example video, it's like about, like, I just go through it like this and then I have to cut the stuff in the middle. I'm thinking about trying to do those a little more conversationally, because I try to do like all math and then I end up overthinking what I say, and I think it'd be easier if I just kind of work through it casually. It's like more of a sit down. Yeah, I'm going to be doing these GRE Prep streams on Mondays and Fridays every week. This Chicago study thing I linked in the comments earlier, but I can link it for you again if you want. It has 6 weeks and then an extra set of problems after that of problems. So I'm going to try to do one of these weeks per week for 6 or 7 weeks, and then aim to take the GRE after that. After I finish these weeks of prep, there are practice examinations, and if I feel like I'm like up to taking them, I might take those blind on stream. And if the first one goes catastrophically wrong, I might do the rest of them prepared, just to do a bunch of problems to practice. Like I said, the GRE is not really taken for credit for graduate school much anymore. It's not going to be counted against me, obviously. They don't usually take it for credit. But for me, it's just like a good way to catch up on all my math, because I am weak in quite a few areas of math due to I have a really scattered background, and I took like Calculus 1 like in 2017 or something. Like, I've taken math for a long time, and there were huge gaps in my math, so I forgot a lot of stuff, and I'm going to try to keep up with it and remember a bunch of it and keep on going. Yeah. Are all GRE questions at this level of difficulty? I don't know. I can't answer that. I'm new to prep too. This is my first prep stream, so like these are the first problems I've done to prepare for the GRE. From what Michael has told me, they are all quite difficult, but I guess it'd probably be better to over-prepare rather than under-prepare. Like, for example, for number 2, I don't really see how I would have solved that on a test, I'll be honest. You probably have to do it a different way. My way would not work in a test environment, but I am willing to bet you can eliminate several answer choices just by looking at it. And if you're taking a standardized test with multiple choice, you definitely want to eliminate answer choices quickly. That will make your life a lot easier. I think a lot of standardized tests is time management, not necessarily like comprehensive knowledge. I think you can, if you can shorten the time that it takes you to do each problem, it'll do you a bigger service than just having a lot of general knowledge. Speed is very important. All right, I think I will move on to problem number 5. Let me write it out. I don't even remember what problem number 5 is. Oh, it's this topology question. Yeah, I thought this one was going to be really hard, but because I initially read it, it's, I don't know if I'm going to write this out because it's quite long. So we have the right topology. So we have the endow the reals with the right topology. And I'll define that for you. I love topology, by the way. Like I said, I only did an independent study. Randolph splits up its classes into quarters now. They're called sessions. So I did this independent study in half of 1 quarter, so an eighth. And I went through like a graduate level topology textbook, and it was just crazy. I mean, I was just putting my axe to the grindstone, but super, super fun. I love topology so far. I feel like I'm still fairly new to the study of it, but I went into a lot of depth with what I've learned. You know, once I finish, you know, GRE Prep and take the GRE, I might do more like independent study, like pick up, you know, algebraic topology and just like go through the book. Maybe I could do that on stream. Just to continue my study of math, because I don't want to sit around and do nothing during my gap year. The whole point of this is for me to like better my math skills, so I'm like ready to go when I get into graduate school. Hopefully I do get into graduate school. So yeah, anyway, let's continue reading the problem. We're going to endow R with the right topology, which is as follows. Come on, eraser. We got tau, I don't know, how do you guys pronounce it? T for topology. This is the definition of the right topology. And, oh no, wrong bracket. And we're going to call that space X. Call space big X. That's pretty standard for topology, is to name your spaces big X. Or I don't even think it's supposed to be X. I don't know. What's the Greek letter for X? Somebody tell me. I could copy paste it, but it's on 2 different devices, so not really. I'd have to like go out of the iPad and it would be a pain. I can send you the link to the questions we're working, and that will probably be more beneficial to you than me copy and pasting the problem, because I don't think I can do that at the moment. There we go. But basically this question, you want to find which of these answer choices is false for a space endowed with the right topology. And so a lot of, you know, topology questions, there's a lot of theory to unpack. For those of you who may have not taken a topology course, topology is very much by definition, it's very detail oriented, and it's a lot of, at least the ones I've worked were very proof space. You need to know a lot of set theory, a lot of number, well, maybe not a lot of number theory, but a lot of set theory and a good amount of like analysis in general. I don't know if you need to know like a crazy amount of real analysis, but the kind of like way you work through analysis is like how you would get through a topology book, because it's all by definition. So if you look at this problem number 5 here, all these answer choices are basically their own proof. But the question is, which one of the following is false? So this is a really good example of a question that you probably don't want to solve by individually proving each of these and finding which one isn't, because, you know, if it's E, you may have wasted like 45 minutes of your time. So when I first saw this question, I was like, oh, this is going to be terrible. It's going to take me a really long time. But then I looked at B. If X is sequentially compact, is answer choice B. And that says that every sequence has a convergent subsequence. Well, it's pretty easy to come up with a counterexample to that, and that counterexample is that the sequence negative n for natural numbers n, it doesn't converge. It does no convergent subsequences. It doesn't converge. or I guess has no convergent subsequences. No convergent subsequences. So that just disproves that, right? And that's fairly easy to see, right? Like a lot of these definitions might be harder to unpack. From personal experience, like some of these proofs, you like look at the definition carefully and you have to like track elements through things and see how things behave in topological spaces. But for this example, like if you just look down the list, you can see one that has like a pretty glaring counterexample. So that would mean that the answer is B. I need to circle. I need to pick something and stick to it. But yeah, the answer choice is B. That is the one that is false because it is pretty easily disproven by observation of this counterexample here. You don't need to spend a lot of time looking it up. Chi. Yes, thank you, chi. Yes, capital chi or chi is the letter that's traditionally used for topological spaces. And I guess psi, that's capital Y, right? Yeah. Those two are used for topological spaces. Or maybe that's not the right one I'm thinking of. But anyway, yeah, big capital X and capital Y, those Greek letters are traditionally used for topological spaces. But yeah, so yeah, this is a good example of a problem where multiple choice is doing you a big favor here because you only have to disprove one. Now, I guess it might be fun to go through and look at each of these individually and prove the other four. But I'm not going to do that because that would probably take me nearly as long as it's going to take me to do the rest of these problems. But, excuse me. If you're interested, feel free to do that on your free time. Like I said, I've been linking the problems in the comments so that you can follow along if you want, or work them out if you want, or disprove all my work if I am terrible at this, if you would like. So with that, I will move on to problem 6, unless we have any questions. Marius says, I hope I pronounced your name right. What kind of math degrees do you have over math major? Yeah, so there is a master's degree and a PhD. There's not really any reason to get a master's degree, to my knowledge, for math. If you're going to use your math degree, you can usually just apply straight out of undergraduate to companies and stuff like that to get a job in the industry. But if you get a PhD, you can go on to like teach at university, and that's more like what I want to do, like and pursue individual research. I guess you could like go for PhD and bail to a master's if you can't get through it. I mean, I'm not trying to say that like a negative thing. Math is a really hard subject, and getting a PhD in math is very difficult. But that would be a way you could get a master's degree. If I am wrong and there's like some job that like really specifically wants a master's degree in math, you can let me know. But those would be the math degrees over like the math major in undergraduate, if that was what you meant by that question. All right, let me get into number 6 now. This is a sum. So here we go. We want to evaluate this sum here, which is from n equals 1 to infinity of n squared, or eraser, n squared over 3n. So let me see. Move my notes over here for my own sanity. So we're going to begin by factoring out a 1/3 here and adding in another case so that we have the following. So we're going to write 1/3 times the sum of from 1. We're adding in the case there, from 0 to infinity. And since we're adding 1 in, we are going to have n plus 1 squared over, and this is going to stay 3n because we factored out that 1/3. And we're going to FOIL that top part out, so that will give us 1 over 3 times the sum from n equals 0 to infinity. Let's see, n squared plus 2n plus 1 over 3 to the n. Here, let me get the chat up. And from there, we are going to split this up kind of in a creative way. So let me show you how we're going to do that. We're going to split this up into, I guess I can write it up here. We're going to have n squared plus n. Then we're going to have a term that's just n. And then we're going to have a 1 here. So we're going to split that up into 3 separate sums. So that's going to give us this here. So we're going to have 1 over 3 times the sum from n equals 0 to infinity of n times n plus 1 over 3 to the n. And that's going to be plus the sum from n equals 0 to infinity of n over 3 to the n. And then we're going to add the sum from n equals 0 to infinity of 1 over 3 to the n. And from here, we are going to factor out a third from these, from all of these, I think. Let me see. Yes, from all of these. So that's going to give us the following. We're going to have 1 over 9. I guess I'll write that as 3 squared. So we can kind of recognize that we've pulled out 2 separate 3s as opposed to just having a 9 there. Times the sum from n equals 0 to infinity. I'm probably just going to stop writing 0 to infinity and just write the sum, but you will get the picture there. Times n plus 1 over 3 to the n minus 1 plus the sum of n over 3n minus 1. I forgot to put my third in there. Plus 1/3 times the sum of 1 over 3n minus 1. Alrighty, now we're going to recognize that we can write these individual sums like this. So we'll have 1 over 3 squared times the sum of the second derivative of x to the n plus 1. And that's going to be evaluated at x equals 1/3 plus 1/3 times the sum of the first derivative of x to the n. And that's going to be plus, oh, and that's also, sorry, that's also going to be evaluated at x is equal to 1/3. And then we can write this last one as plus 1/3 over 1 minus 1/3 by geometric series. And what's that going to be? 1 minus 1/3 is 2/3. That'd be 3 halves. 2/3, flip it over. I don't know why I'm failing on simple math. I'll go back to it. So we can use geometric series on the other two. We just started with that one. We're going to have 1 over 3 squared times the second derivative of x over 1 minus x, evaluated at x equals 1/3. This is also by geometric series. And then likewise, we will have 1 over 3 squared. Is there a 3 squared? No, it's just 1/3, right? For, let's see. For this geometric series, it's just 1/3, right? I'm checking chat. 1/2, 1/3 over, so 1/2, 1/3. Is it 1/3 or 1/2? I don't know. I don't know. Let's see, for geometric series, one-third? Okay. So 2/3 is just 1/2? Yeah, it's 1/2. This first one's 1/2. That's what I thought, yeah. So this is gonna be 1/2. And then this is 1/3 over here. That's what you were saying, right? Yeah. So by geometric series, we have 1 over x should be x minus 1, right? 1 minus x, sorry. I need a derivative in there. D over dx of x over 1 minus x. And this is just going to be 1/2. So let's do those derivatives. I kind of ran out of space, which is unfortunate. So I'm actually just going to erase because I think I've been using too many pages. I can just make more. All right, so the second derivative, let's just take the first derivative of that first one. So we have d over dx of x over 1 minus x. So we're going to use the quotient rule there. So that's going to be equal to, let's see, do I have this? No, I didn't do this out in my notes, so we're just going to do it live here. I believe it is, it'll be x times the derivative of 1 minus x, which will be negative 1. So x times negative 1 minus, and then 1 minus x times the derivative of the first one. That would be times 1 over the bottom one squared, right? So 1 minus x squared. Please correct me if I'm doing the quotient rule wrong. That'd be pretty bad. And that's evaluated at x equals 1/3 once again. And then we will take the derivative of that. And that, I think that's just the, yeah, it's the same for both of those. So that's just the answer for the middle term, is 1/3 times that. And so we're going to take the second derivative, so that will be the derivative of be negative x minus 1 plus x, so those x's cancel there, over 1 minus x squared, right? And what is that equal to? I feel like is that an identity? Is that an identity? I don't, no. So that's going to be the derivative of, let's see, negative 1 times 1 minus x squared to the negative 1. And that's going to be equal to, did I miss a square? Oh, I put the squared on the inside. Yeah, that changes things, doesn't it? That changes things. Thank you for catching that. All right, so that's equal to, by the same token, yeah. Let's see, that's negative 1 times 1 minus x to the negative 2. And then we got to apply chain rule to that, right? So it's going to be, what, 2 times, I'm embarrassing myself, aren't I? 2 times negative 1? What am I talking about? No. I'm tripping. Negative 2, that's going to be equal to negative 1 on the top, right? So it's going to be 1 over 1 minus x to the to the 3. Yeah, like to the negative 3 on the bottom. Like that. The negatives cancel on the top. I've been doing great. Yeah, I've been trying. And so of course I got to fumble on calculus 1. But I think it's equal to that. Maybe I should calc it since I'm not sure. It's the benefit. I'm studying. I mean, can't get it all perfect. This one is largely not been done. Let's see. And that'll be, yeah, I think when you're studying, you shouldn't be afraid to look stuff up, because the whole point of studying is that you're like learning, right? Like if you knew it, then you wouldn't be studying, right? And that's kind of the point here. So let's see. Yes, it is. I messed up the top. It's so close yet so far. I think I just added my negatives wrong in my head. I don't even think it was a major mistake, because that's, you add 2. Yeah. So it's going to be negative 2, not negative 1. Just subtract 1. It's beautiful. Yeah, so I just messed up my negatives there. But let's see if I can even piece this back together. So we'll have 1 over 9 times this thing right here, which is the second derivative for x evaluated at 1/3. Negative 2 over 1 minus, let's see. I just had a feeling that was wrong. Glad I checked it. And that's going to be evaluated at x equals 1/3. And that's going to be plus 1/3 times that first derivative there, which gave us, what was that? The x's cancel, right? So it's just -1 over. So 1/3 times -1 over 1 minus x squared plus 1/2. And that's for x equals 1/3. So let's plug that in and see what we get. We'll have 1/9 times -2 over 1 minus 1/3 cubed plus 1/3 times -1 over 1 minus 1/3 squared, and that's plus 1/2. So this is going to be 2/3 cubed, and that's going to be, what, 8 over 27 in the denominator there? 1/9 times 8 over 27, multiply the 27 up. What's that? 27, 54, -54. And then over 8, which we can simplify. Is that wrong? Correct me if I'm making simple mistakes here. And then that 2/3 is going to be 4/9, and the 9 is going to go to the top. So we're going to have 1/3 times -9 over 4 plus 1/2. And let's see, how does this simplify? I'm just going to plug this in. Well, yeah, I'll plug it into a calculator. Save myself some time, right? Let's see. If anybody has it faster than me, please let me know. So we've got 7. So that's going to be 27 over 4. The 27 is going to cancel with this 9 here. That's going to give us 3. So that's going to be -3/4 here. Right? And then this 3 is going to cancel here with this one, and that's going to also give us -3/4 plus -3/4, and then plus 1/2. Right? Let's see. Make any mistakes? So -3/4 plus -3/4 is -6/4, or -3/2 plus 1/2 is going to be -3/2 plus 1/2 is going to be -2/2, which is -1. Is that right? Or did we mess something up along the way? That's not an answer choice. Well, that's not good. Let's see. What did we mess up? Probably the derivative somewhere. Or possibly just the fraction simplification. I ran out of room. I got greedy. I should have just written it out. Let's see. Anyone see the mistake? Yeah, I got -1, but I don't think that's... Well, I know that's not right because it's not an answer choice, but I think it's just off by arithmetic at the end here. Let's see. Can I just plug this in and see what the actual answer is? Alright, let's see. It is supposed to be 3/2. So, do we drop a minus sign? These are all pluses. Miss a minus sign here? Let's see. Is this first derivative correct? I don't want to spend too much time on it. I think it's just in the arithmetic here at the end. If not, it's a simple differentiation mistake. Yeah, -2. So it's supposed to be 3/2. Two in the second derivative. Like a positive 2? No, that wouldn't do it, I don't think. Would it? That would do it if it was a positive 2? I guess that would make sense because, yeah. So if it works when it's a positive 2, I'm just going to say that's it. And then if I'm wrong, I'm sure we'll get comments about it later. Plus 2, 3 halves. I'm just going to go with that. In the first line? Where is that? Up here? This is the point of studying. Apparently, got the hard stuff right and the easy stuff wrong. That's how it goes. How about this? I will move on, and if someone is able to articulate the mistake, I'll go back and fix it. Should have been let's see, 1 times 1 minus x. Oh, I subtracted the wrong ones. So you're saying all my signs are wrong. So this should be plus, and this should be minus. And the denominator is the same. I gotcha. Okay, so then if that's the case, we get for here, we get the 2 x's will combine, so we'll have negative 2x on top, right? The 1's will cancel and the x's will add instead over 1 minus x squared, like that. And then we will take the, so then we'll have to use product rule again. Okay, so let me just, if that's the case, let me just erase here. Okay. Whew. So then we will have to take d over dx of negative 2x over 1 minus x squared, and that's going, oops, that's going to be equal to 1 minus x squared times, I guess I'll put negative 2 minus negative 2x times what would that be? 2 times, I don't even remind me how chain rule works. Is that 2 times the derivative of the inside, which is just going to be equal to negative 1, like that? No. And then that's times 1 minus x, right? Like that. I think that's how it goes. And that's going to be all over 1 minus x to the 4th, because it's that squared. Alrighty. I'm not really sure how we simplify this off the bat. Maybe we just don't and plug it in. Just leave it alone. Might be easier to do. Not really sure. This is going to be a pain to simplify. I might just move on. I don't really want to go through all the arithmetic and use another sheet and a half of paper on it. But I'm going to assume that we're on the right track here with this. Because, yeah, I understand why that would mess it up, because we're missing a whole, we got to differentiate more terms and stuff. Anyway, maybe we'll come back to it after we're done. Which problem was that? It was number 6. So I guess we'll go on to number 7. And number 7 is, let me get the sheet up. Okay. For those of you who have been watching my number theory example videos, this will be my test, right? What is the remainder of 13 to the 2019 divided by 95? Or rather, what is to restate it more in number theory terms, what is 13 to the 2019 mod 95? Now, let me check that. Yeah, so remember that you can reduce the exponent mod phi of the, which you're taking the base mod. So we only want to start by calculating phi of 95. What is 95? It's 5 times what? Let's see, 95 divided by 5, 19. So that is prime. So we will have phi of 95 is equal to 95 times 4 over 5 times 18 over 19, and I believe that is, let's see, let's just look it up. Yeah, that is 72. 72. So we're going to want to reduce our exponent mod 72. So 2019 mod 72. So let's see what that is. We have 2019 mod 72 is 3 mod 72, and that will give us 13 cubed mod 95, and 13 cubed is 12 mod. Oh. Oops. Oh dear. That was terrible. Got jump scared. Okay, so 13 cubed mod 95 is 12. That's what I was saying. It's congruent to 12. I have do not disturb on, so I don't even know how that got through. Oh, that's on the computer, not on the... they get you. They get you. Yeah, that's Grace from the podcast, I think. It's a Michael Penn classic. You can also use the fact that phi... Yes, you can do that. Yes. Yes. All right. But yeah, this is equal to 12 mod 95, and that finishes the problem off. So are there any questions on that? I think I'm going to sneeze. Oh, no. No bots. Kill the bot. How do I ban? Put user in timeout. I'm going to hide him on the channel. There we go. Uh, 4 over 5, 18 divided by 19, y. I'm just using a shorthand for calculating Euler's Quotient function. That's why I'm writing like that. So if you know how to calculate Euler's Quotient function, you can see that that's equivalent to like what is formulaically usually defined for it. It's easier for me because it's just less steps, but I mean, for some people that prefer to have it out, or like have it written out, you know, then yeah, no problem. All right, any more questions on this before I move on to question number 8? Nope, I think we're good. All right, so let's see what number 8 is. Oh, it's this limit right here. Yeah, this one's pretty tough too, honestly. So we have the limit as n goes to infinity of product from k equals 1 to n of k over n to the 1 over n. All right, so hello. Nice to have you out. Come out. So the general rule for taking a product to a sum is you take the log. So we're going to call this thing, ignoring the limit, this right here, p sub n. we're going to take the log of p sub n. And like I said, the rule for that will give us the following. We'll have the sum from k equals 1 to n of 1 over, oops, I'd like to switch to that eraser. I think it's when you like put the pen on its side, or maybe it's like when you tap it on the screen or something, it switches to the eraser. But it constantly happens to me. If anyone knows how the Apple Pencil works well enough to tell me what I'm doing wrong, please let me know. It'll save me a lot of time. But yeah, 1 over n times k over n. Double tap. Okay, yeah, that's super helpful. Thank you. Yeah, I will. Is it like double tap on the pen with your finger or tap on the screen? Just curious. Yeah, because I like tap the pencil plenty of times when I'm using it. I don't actually know. These things are too smart for me. I'm not used to the technology. On the pen. Okay, that makes sense. Yeah, I'll probably just turn that off in settings because I'm probably never going to use that. But it is, I guess, sort of convenient. But yeah, I have a lot of fancy stuff thanks to Michael to do these videos with, and it's really nice of him to. I'm giving him back, obviously, but to allow him to let me use these to study with and stuff like that. But anyway, does anyone see where we're going to go with this? I just want to ask that question. It's interesting. Does anyone recognize this sum here? No? Nothing? Perhaps? It's the Riemann sum. Why did it take do not disturb off? I don't know. So that lets us write this. We can write the natural log of p of the p sub n is the integral from 0 to 1 of the natural log of x dx. Yeah, exactly. And we're going to do this integration by parts. There are 3 rules for integration by parts. I believe it is inverse functions, transcendental times non-transcendental, and 2 transcendental numbers. I might be wrong on that third one. But this is an inverse function. Natural log is an inverse function. So we're going to do this integration by parts. We are going to let dx equal dv, and we are going to let u equal the natural log of x. So that'll mean our v is equal to x, and our du is equal to 1 over x. So we will rewrite that in the following way, or we'll evaluate that like this. We'll have x times the natural log of x evaluated from 0 to 1 minus the integral from 0 to 1 dx. And I believe, let me look at it real quick, that is just equal to, let's see. Oh no, we have to do something with this first. Hold on. So we need to, because of this 0 here causes us problems. It's undefined in the natural log. So we're going to need to write that as the limit as t goes to 0 from above of the natural log of t over 1 over t, and that is going to go to 0. And then we are going to get a -1 from this part fairly obviously, so that gives us -1. Now, are you thinking, shouldn't it be the integration of x dx? Where did I miss that? Am I missing something? When I plugged it in, is that what you're saying? Anyway, so you're actually not done here. Because if you recall, we took the log of p sub n at the start, so we're going to have to exponentiate our -1 here at the very end, and that will give us e to the -1, which is hopefully an answer choice. Hopefully an answer choice. We've only missed so far. Yes, it is. That is B. Yes. So don't forget to exponentiate. If you're going from a product to a sum and you just so happen to get to a Riemann sum, if you're in that specific of a situation, do not forget to exponentiate at the end. So of e to the negative 1 for our final answer. All right, we don't have many problems left now. Oh, I'm out of sheets already. I told you I was getting greedy. I was using too many sheets. Let's rotate this so it's horizontal for us. Alrighty, I think this next one is a Calculus 3 problem, so that'll be fun. Yeah, so this is a Calculus 3 problem using polar coordinates. So we're going to let, A equal this annulus. This is going to be our region of integration, which is on R2, such that 1/2 is less than or equal to the square root of x squared plus y squared, which is less than or equal to 2. Those are going to be our bounds of integration. We're going to want to evaluate, here, let me put the number here. This is number 9. Put it tiny in the corner. Evaluate the following double integral. We have the double integral over this region A of 2x minus 2y e to the x squared plus y squared dx dy. Now, if you see this, you should be thinking polar coordinates. We should be thinking polar coordinates. Are we thinking polar coordinates? We should be thinking polar coordinates. So we are going to, hopefully you guys remember your polar coordinate substitutions. We have x is equal to r cosine theta, y is equal to r sine theta, and our bounds of integration are going to be r is from 1/2 to 2, and theta is 0 to 2 pi, as is fairly standard. Alrighty, so we will now rewrite our double integral using those substitutions there. So we have 0 to 2 pi on our outer integral, and then on the inner integral we will have 1/2 to 2, and that will give us, oh come on man, yeah, I got to turn that off in the settings. We'll have 2 r cos theta minus 2 times r sine theta, and then we will have e to the r squared. Oh yeah, I forgot to write that for our r is equal to x plus y, right? Is it x squared plus y squared? X plus y? Why am I forgetting this? Hold on one second. I don't know why I'm like forgetting this. I think it's just x plus. No, it's, yeah. Well, anyway, this is going to be e to the r squared, r d theta, or dr d theta, not d theta dr. That matters? That does in fact matter. All right, so we are going to write this as a, hold on, let me see here. If you go to the eraser, you can switch it off in GoodNotes. That's actually very helpful. Thank you. Yeah, I don't see it there. Disconnect the pencil. Unless yeah, I don't know. Alrighty, let's see. So we can split this up and write it as a product of two integrals. It's going to be from 0 to 2 pi of, let's see, cosine theta d theta. Yeah, no, I'm sure there is, but I can just do it after the stream. I appreciate the advice because that's going to be helpful to me in the future for sure. And then that's going to be times 1/2 2r squared dr. Like that. Right? No. Like I'm missing something immensely important here. Where did my sign go? My notes are... Am I missing a step in my own notes? That's pretty impressive. Does anyone see my logic that I don't see? Where did my sign go? It's gone. Yeah, you can write, if you have the product of two functions of variables, you can write them as a product like this, but is it like a factoring thing? I just forget to write something? I think there's just supposed to be a sign in here, dude. Oh. Right, because you factor out... Are there missing parentheses on what? Split it up into two integrals and split those up into two integrals? Yeah, so let's just do this slowly so we don't screw it up. All right, so let's distribute our r through so we can split it up like directly. So that'll give us 0 to 2 pi 1/2 to 2, and then we'll have 2r squared cosine theta minus 2r squared e to the r squared dr d theta. Right? And then... did I just drop the sign again? Dude. Yeah, I completely just... I just don't like sign. It's not my favorite function, I'll be honest, apparently. I hate it enough to ignore its existence multiple times. Minus 2r squared sine theta e to the r squared dr d theta. So we want to, let's see. Integrate the theta first. Yeah, we can switch bounds of integration, but there's a trick here. I wrote it in my notes, I just forgot what I did to do it. I think I skipped too many steps. I don't know if multiplying out is the right way. I think I'm missing a substitution here. Studying. Yeah, this is more like, yeah, so you're getting the authentic studying experience now. It's just getting stuck on stuff you already know, right? Let's see. Is it like a definition? I feel like I'm missing a polar substitution here, like with relating cosine and sine and stuff. Because in my notes, I had just dropped a sign and then showed that both go to 0. Both halves go to 0, so the integral is 0. Is 0 even an answer choice? That would be a good way to see if that's blatantly wrong or not. No, it is an answer choice. Huh. You sure it's not 2x minus 2y e to the x squared plus y squared? Are you saying I copied the integral down wrong? 2x plus? Is that what you're suggesting? Is that there's a plus there? No, 2x minus 2y. Oh, times, like, there's parentheses missing. Yeah, no, there's no parentheses missing there. Not at all. Yeah. I think I'm missing a substitution or something. Let me see. Because the way I did it is I split it up so that you could split it up as the product of two integrals by factoring out properly, but I don't know how I did that anymore. You can factor out a 2r squared there pretty obviously, right? But that doesn't really help us unless we get rid of the e and the sine. Theta should be 0 to pi. You only consider the semicircle. You can rewrite sine in terms of cosine. Yeah, we can do that. Oh, maybe that's what I did. I think you're right. It's 1 minus sine, right? 1 minus sine theta. What's the? Somebody give me the identity so I don't have to look it up. I forgot. I haven't done polar coordinates in forever. Calc 3. Oh, I guess I can derive it from what I have right here, right? Because it's r is equal to. Let me just look it up. It'd make my life easier, right? Polar coordinates. Let's see. Get the conversions. I should know this off the top of my head, but like I said, it's r. Yeah, it's r squared is equal to x squared plus y squared. Yeah. So r squared is equal to r sine theta squared. Yeah. Oh, it's just. Yeah. So here, let me write that in. That's our missing thing. First of all, we have r squared equals x squared plus y squared. That's our third polar thing. What I'm trying to accomplish, I am trying to figure out how to solve this integral, but I have, basically in my notes, I simplified it, but I think I'm missing a, how I substituted, and I completely forgot. So, yeah, so that, let me see. Rewrite sine in terms of cosine and then split it. Yeah, what I had was just terms of cosine and r. Like the e disappeared. That's the part I don't get. That was magic. Or did I just write it down terribly? I don't. Huh. Shift. I don't think we need to multiply it. I don't think we need to do this. Or rather, it doesn't really matter. Like, it's not going to be to our benefit to write that out because it doesn't give us any more information. I think we want to substitute in here somewhere. So, yeah, let's see. Yeah, x over r and sine is y over r. Yeah. That doesn't super help though, does it? Maybe u sub r squared. Yeah, for what though? Yeah, what I had written in my notes is the next step, as if it couldn't be possibly more obvious. Past me was infinitely smarter than current me or something, or just dumber. Add this times, and have squared, yeah, like this, 2r squared dr, like that. That's I had this literally as the next step. Like that just goes there. Split the integral in sum and consider theta as a constant when you solve the first integral in terms of r. Yeah, that's yeah, I guess you could do that. Split it and consider theta as a constant when you solve the first integral in terms of r. Yeah, I don't know if that would solve, I mean, maybe it would simplify it. Let's try that. So then we would have this integral 2 times, and then we would have 2r squared cosine theta dr d theta minus 0 2 pi 1/2 2r squared sine theta, oops, e to the 2r dr d theta. Oh, is that what it is? Oh. If sine is odd, it goes to 0. Is that a thing? I'm not a... Yeah, I think you're right. I think you're exactly right. Yeah. I think because sine is odd, it goes to 0. Yeah. And that's how we get... Yes, you're exactly right. Yeah. Yeah, so this goes to 0. It's odd. And then that gives us this. 2, and then we'll have 2r squared cosine theta dr d theta. And then we can split that up as I had in my notes. Yeah. And then that'll give us cosine theta d theta. And then this will be 1/2 2r squared dr. And then this goes to 0 pretty obviously because it's 2 pi periodic, and if you subtract the top from the bottom, you're going to get 0. And from here, it's not quite as obvious, but when we plug in just from eyeballing it, we're going to get 1 minus 1. This is going to go to 1 minus 1, which is equal to 0. So that makes this whole thing 0. Anybody want to confirm that? Yeah. I think that's right. Yeah, thanks for pointing that out. Yeah, no, I like I said, this is just slipped my brain. You don't think it's right? I don't know. I think it is. Might be wrong though. Yeah. I'm just gonna move on. I don't want to dwell too long on this. I think, like I said, I'm studying. I'm gonna go back after this and do more. But I just don't want to sit here on camera and not know what I'm talking about. But I'm pretty sure it's the oddness. I think he's right. Or at least that's what I thought it was when I wrote this out. Alright, I need the... Let's see, what's the next problem? I gotta add a new page. Yeah, if it's incorrect, I will figure it out later. I might even post a correction in the comments if I find like a simple way to explain it. See, this is problem 10. Okay. So, problem 10 says, which of the following functions are holomorphic with x and y and r? I'm going to write those functions out for you. I think we're going to use Cauchy-Riemann equations to do this. And that's equal to x squared plus I y squared. That's the first one. We just want to see which of these are holomorphic, which I believe is like just, here, let me actually read the definition of holomorphic. So in mathematics, a holomorphic function is a complex valued function of one or more complex variables that is complex differentiable in a neighborhood of each point in a domain in complex coordinate space. Yeah, so we can use Cauchy-Riemann equations for that. And I need to look those up because I don't remember them off the top of my head. And we're going to, here's the next one. Let me just finish writing these out. I got distracted quickly. y is x plus x squared minus y squared plus I times 2xy plus y. And then the third one is going to be, need to get another one in there. There we go. H of x plus iy is equal to y plus e to the x cos y plus I x plus e to the x sine y. That one's pretty long. Let me check the chat. All right, so let me look up these Cauchy-Riemann equations. I believe I have my notes just behind me for those. They're somewhere in here. You're getting the authentic studying experience, which is doing a lot of problems and a lot of figuring out what you don't know. But I mean, part of this channel, we're trying to kind of document what it actually looks like for an undergraduate student to do a bunch of problems. So I think it's good to see that we're not infallible, right? I'm certainly far from infallible. Where are my notes? Did I put them in here? Yes, complex analysis. Kosher-Riemann equations. Does anyone happen to remember what course video from complex analysis Kosher-Riemann is in? Let's see. See how long it takes me. It's been a long time since I did this. Complex analysis. Complex analysis is really fun. What is you guys' favorite math class? Or I guess subject is better. I don't feel like class math doesn't really constrain the confines of a class. It just has subjects within itself. Let's see. Maybe faster just to Google Cauchy-Riemann equations. Took such nice notes. Trying to get it really quickly here. I think it's going to take me too long to find it here. Number theory were your favorites? Yeah, we're planning on doing a lot more courses on this channel. But it's going to take us a while to produce them, obviously, because we want the content to be good, and also we're trying to do the main channel and all that stuff. But we have them in the works. I think Michael had planned at least a topology course and an abstract algebra course to go kind of with the linear algebra as a continuation. And I'm not sure what else. I think there were a few others he had in the works that he's mentioned to get these Cauchy-Riemann equations. So we have du, all right, partial u, partial v with respect to x. We just want to verify that these are true. And if we can do that, then we will verify that they are, let me see I forgot what the term is, holomorphic. And then we have dv, dy, and du, dy is equal to dv, or negative dv dx. Oops, that's a w. I don't know how I got those confused. The dx. Alrighty. Let me just make sure I know what u and v is talking about first. Yeah, the real part's u and the imaginary part's v. Okay, that's what I thought. Oh, you're writing, yeah. Thanks, Chad. You helped me out. Yeah. See, I took all that time to look it up, and it's been sitting here in chat. Thank you very much, Abraham. Yeah, u is the real part. So we're going to want to integrate the real part with respect to x and see if that's equal to the imaginary part with respect to y. So let's start off with the first one for I. I'm just going to erase this bottom portion as I do each one. I don't want to go into new pieces of paper because we're already out, if you will. And also that'll keep the Cauchy-Riemann and the other ones there. So for I, we will take the derivative with respect to x of the real part. That's going to be 2x, very easy. And we want to see, here, I'll write that out a little better, actually. du dx is equal to 2x. And then dv dy is going to be equal to 2iy, right? So that's just not true. So we can already cross this one out. Those are not equal. And I might be able to do the next one down here. So let's see. Got for part 2, du dx. So for the second one, we will have 1 plus 2x, and that y term is going to go away. That 2 looks like one of the, just like 2x. Right, I like that, so it's more clear. Oh, I gotta ban another bot. Have you guys seen these bots other places? I don't know. They're just everywhere. Like, all these chat bots on everything are crazy. Like, I've seen chat bots on pretty much, like, every platform, and I don't feel like I used to see them. You know what I mean? It's like a more new phenomenon. I'm not really sure why people are chat-botting everything now, but it's, like, everywhere. On every platform. But usually it just gets deleted, but it's really annoying. Okay. So then we're going to do dv dy. So the imaginary part is going to be, let's see, 2x. Yeah, that's 2x plus 1. So that one works for the first equation. Now we're going to want to check the second equation, and that is du dy. So taking the derivative with respect to y for the first one, we're going to have negative 2y. And we want that to be equal to negative dv dx. So dv over dx is going to be equal to, let's see, that's just 2y, but that is in fact negative du dy, so that's checked. So we know that 2 works. We'll just do a big check up here. I read them down wrong. Kosher, Riemann. Let's see. So I times v of xy is the imaginary part, so divide by I. Oh, I see what you're saying. I needed to, if I, for like doing the derivative of this part, there's going to be an I there, which I just didn't even write down. Let's see where would that be a problem. I'll add that in. Yeah. For this, so this would still be 2x. This 2x would be 2xi, but I would need to divide by I. Or divide out by I. I think it's still fine, right? Yeah. Anyway, I think 2 works. Yeah, I gotcha. Are you saying I did the first one wrong? Well, no, because I see the I wouldn't be here. That's what you're saying. You're saying that this was just 2y, not 2iy. But it doesn't work either way. I gotcha. And then for 3, we will take the derivative with respect to x of the real part, and that's just going to be e to the x cos y, right? Here, let me back this up. Yeah, I'm sorry if my brain's not firing on all cylinders today. I did not get very much sleep last night, I'll be honest. Is equal to e to the x cos y, and dv dy. The imaginary part is not that. It's not that. It would be, oh no, it is that. Equal to e to the x cos y. My picture blocks a lot of the question. Oh, it does. I can move myself. Hold on. I got that big block there now, though. That kind of sucks. Well, it's not in the way of the question anyway, so I'll just move it back afterwards. Yeah, so e to the x cos y, so that works for the first one. And then du dy. So this will go to 1, and then this will be negative e to the x sine y, and then dv dx will be 1 plus e to the x sine y, right? But that's slightly wrong because of the negative. This is cosine. Right? That's wrong because the negative would distribute to that 1 and mess it up. Am I wrong? Can I make the picture thinner? I can, I just don't know how to do it right now. I know that I can crop this. The reason this is here is because there's a shelf right here. And I just had it cropped off the top because I, usually keep the camera in the same place, but just like move it over a little bit there for you. But yeah, I think, is the -1 going to mess this up? Is this not going to work? Because negative dv dx here is going to be -1 minus e to the x. Wait. No, I just wrote this wrong completely. So we are trying to find dx here, so that's going to be 1 plus e to the x sine y. Yeah, I don't know why I wrote cosine. I was like differentiating wrong. And then like negative dv dx is equal to -1 minus e to the x sine y. So that doesn't work, right? Or did I mess up my signs? I think that's right. Yeah, it doesn't work. It's unfortunate. So close yet so far. Let me just check and see if... Yeah, 2 only is answer choice B. So assuming I didn't like drop a negative or write the problem down wrong or something. That is... Yeah, there's no negatives in any of these. Except for this minus y squared on the second one. Okay, yeah, so that's answer choice B there. And then, so we're going on to the last one. Now the last one's actually easy. Sorry to disappoint you if you've made it this far. The last one is, this is a abstract algebra question. And this question says, let R be the group of non-zero real numbers. Here, let me move my picture back so it's not all scuffed. There we go. Yeah, so let R be the group of the non-zero real numbers under multiplication, and we're going to define, define A, let's do this for star, A star B is equal to the absolute value of A times B. And we want to like verify each of these statements and see if they're true. So the first statement is that R in star has a left identity. And we can see that that's true because we can plug in 1 or -1 for A and get the identity there. But we can also see that R star does not form a group, which is number 3, because 1 and -1 both are an identity, which means it doesn't form a group, R and star. I didn't write it explicitly, but this is, we're letting R be a group under multiplication, not under star. So here we're saying that R star is not a group, but we've defined our group in this problem statement as R being a group with multiplication. This is what we're talking about. Like regular multiplication. But yeah, we can see pretty easily that we will have a left identity. So if there is a value we can multiply from the left to get the same, and that would be pretty obvious. So R star, I guess like does R star form a group? Let's put a check here. Group. No, identity is not unique because of that absolute value. 1 and -1, big no-no there. And then kind of just doing these out of order, but 1 and 3 are linked together, so it makes more sense to do it like this. So this is R star is left cancellative. I think that's how you pronounce it. Cancellative. I.e. A star B equals A star C implies B equals C. And that's obviously going to be true because if we're talking about from the left, that works. Because there's no absolute value to deal with on the B and C terms. But if we were talking about from the right, that would not work. So is left cancellative? That is true. This is an x. I'm not going to do a proof for that. It's just fairly obvious from observation, right? Equals a star c implies b equals c. Yeah, so the answer for that is that 1 and 2 are true, which is answer choice D. And that is the last problem I had planned for today. So yeah, I think I'm probably gonna wrap it up. I don't really. It took a couple hours, 2 hours. Michael said it'd take 2 hours. I was like, no, I don't think it'll take 2 hours. It took almost exactly 2 hours. So he knows. He knows. Let me open up chat so I can talk to you guys. Yeah, I just want to thank you guys for coming out. Yeah, no, I really appreciate it. I will try to prepare the next 11 problems with a little more certainty and have better answers to your questions. Obviously, like I said, I am studying. I'm just recently graduated undergraduate student, so I'm by no means an expert on this stuff, but I'm doing my best to, here, let me move my picture so you can see my solution. Oh, I need to fix that. That's just terrible. Here, I'm just going to turn my camera off, actually. That way you can see the whole thing. But, yeah, thanks for coming out. I really appreciate it. Yeah, it was nice talking to you guys. I'm going to have another stream on this Friday. Like I said, probably sometime between 11 and 1 o'clock. Basically after I eat lunch, probably closer to 12. I might start, a schedule, like have an actual time. But as of right now, like I have too much stuff going on. I've just recently moved into this house, so like I've got like a lot of stuff that I have to do for it and all that stuff. But yeah, thanks for coming out. Yeah, no, I think that's kind of the point of this. Like I'm studying for the GRE, so because I'm studying, I'm not going to be an expert on it, and I'm going to review the problems and try to find like what I didn't understand fully later, and then maybe I could open with those next time. I'm not sure, but anyway. Thanks for coming out, guys. It was good talking to you, and I guess I'll see you on Friday, and keep your eye out for the example video tomorrow.